We're just going to actually execute the commands here in a particular data set for predicting an outcome using the linear combinations of a couple vectors from a coefficient matrix or from a design matrix. So I'm going to use the data set mtcars. I'm going to do data mtcars. And then here's the first couple of rows. And I want my y to be mtcars miles per gallon, and I want my x to be a matrix that has a vector of ones, a weight vector, and horsepower. Okay, so let's just check head of x. Okay, now we know that the best predictor of y that's created as the collection of linear combinations of the columns of x is solve inverse of x transpose x times x transpose times y. And there it is. We can check this with R's LM function. We have miles per gallon as the outcome, and we had weight as a predictor and horsepower as a predictor. And this is what the LM function does automatically. Oh, and let me just grab the coefficients. And you can see they're identical. Okay, so that is our equation. Let's write it out one more time. Our equation, if we have a vector y, an n by 1 vector y that we're interested in predicting with an n by p matrix x, and we want to predict y or explain y with linear combinations of the columns of x, the best estimator of the collection of column weights is x transpose x inverse x transpose y. And we just saw that when we did that, we got these collection of numbers throughout the class. Now we're going to talk a lot more about how to use those numbers and more about their statistical properties.